So this video is about tips and shortcuts. So we'll do some approximations to get results quicker and without by avoiding some harder manipulations. So it's about converting between kilograms and pounds. Okay, continue here. This is video number 16, part 2 of 5. I divide this video in 5 parts, and this is the second part. Okay? And let us continue. Let's continue with next section here. Next section is about converting between kilos and pounds. Let's convert from kilos to pounds. Okay. Conversion is given by 1 kilogram is equal to 2.2 pounds. That's what we are going to use. 1 kilogram is equal to 2.2 pounds. Okay. And we are trying to avoid multiplying by 2.2. Let's continue here. So 2.2 is 2 plus 0.2 pounds, okay, is equal to, so n kilogram must be equal to 2 plus 0.2 times n pounds. Okay, let's continue here, and that's equal to 2 times 1 plus 0.1 times n pounds. Okay, so this is the workout that we're going to do. We would do this. Instead of doing 1 kilogram is equal to 2.2 pounds, we would try to implement it 2 times 1.1. Okay, let's continue here. So first step is multiply by 2. Okay. Second step is add tenth of multiplication. This first step. Whatsoever we get from first step, we'll add tenth of that. Okay. Continue here, and that get me the desired pounds. Okay, let's go to example. 32 kilogram is 2 pounds. Multiply 2 by 2, which 2 times 32, which is 64. We started with 32, now we have a 64. Okay? Now we're going to add tenth. Tenth of what? Tenth of the 64, not of 32. Tenth of a 64. So 64 plus 6.4. How do you get tenth? By moving a decimal place to the left by one place. Okay? Okay, this is like divided by 10 is drawing a line to the left of one digit, and that's where decimal goes. 6.4. 64 plus 6.4 is 70.4. 10 is a base number, and division is just moving the decimal place to the left. 64 plus 6.4 is 70.4. So 32 kilograms is equal to 70.4 pounds. Okay, that means 32 kilogram is 70.4 pounds. Let us continue. Now let's go backward, converting from pounds to kilos. Okay. Now we'll use an approximation. We'll use the reversal method here. First, last time we did add a tenth. Okay. Okay, and to reverse, we have to subtract a 11th. We added tenth of 2 times n, that is n by 5, which would be 2.2 times n divided by 11. So we have to get a real reversal, to revert the results, we have to subtract 11th. Okay, but we will do approximation here. Step 1, we need to subtract 1/11th of the pounds. Step 2, we would divide that by 2. Okay, let's continue here. But we don't want to divide by 11. Okay, you can divide by 11, which is not that bad, and use transpose and apply method of division. We can had that discussed that division by 11 in this video here. Continue here. Let's continue. Okay, now division by 11 straightforward using transpose and apply method of division. In this section of shortcuts, we are using division by base numbers like 10, 100, and 1000, etc., etc. Let's continue here. Note 1 over 11 is equal to 0.09090909. So 0.09 is a recurring number for 1 and 11. Okay, and also that's equal to 1 and negative 1, 1 and negative 1, 1 and negative 1, and 1 negative 1, because 0.9 is equal to 10 minus 1. Okay. Let's continue here. So that is equal to sum of terms like minus 1 to the power I times 1 over 10 to the power I plus 1 for I equal to 0, 1, 2, 3. Okay, so this thing can be represented as a sum of the terms like this. Okay. Let's continue here. For a crude, usually good approximation, we subtract a tenth, okay, which is the first here. We just say, okay, we're going to truncate this series here up at this place here. We won't do any further, so that give me we can get an approximation by using a subtracting a tenth instead of 11th. For better approximation, then we go do another add another term here, add it 100. So we truncate the series here by adding 100. Okay, okay. And we for further better approximation, we can subtract a thousandth and add a 10,000th. But let's see. So first approximation usually good is we subtract a tenth. So that means we truncate the series right here. For still better approximation, we subtract a thousandth here. That means we're going to truncate the series here. Let's consider example of converting from pounds to kilos. Okay. So let's do the same example here. Let's convert back 70.4 pounds to kilos. Okay. Reversal method. For exact calculation, we'll subtract 11th of 70.4, and 11th of 70.4 is 6.4. You can divide by 11. 11 times 6 is 66, and then 4 is the remainder here, dot here, and with 4 remainder from here, and next digit 4 become 44, and 11 44 divided by 11 is 4, so 6.4. Okay? So we'll subtract 6.4. 70.4 minus 6.4 is 64. Okay? Next step is divided by 2. We just the reversal method. Okay, first we subtract, then we divide. 64 divided by 2 is 32. So we got back to 32 kilograms of the previous example. Let's continue here. However, in this section of shortcuts, we are trying to get a quick and dirty approximation. Quick and usually good approximation. We also wish to avoid dividing by 11. So division by 11 is not that bad, but we still want to. It's a Vedic math, short and also shortcut. So an approximation. So we are trying to avoid dividing by 11. Okay, so let's do the approximation now. Convert 70.4 pounds to kilos. Let's continue here. Step 1. Subtract a tenth, that means 70.4 minus 7.04. Tenth of that 70. Is 63.36. Okay, let's get it. Then add a hundredth. Hundredth of what? Of this thing here. Of 70.4. 63.36 plus 0.704 is 64.06. Okay, for better approximation, subtract a thousandth. So 64.064 thousandth of that one. That's 0.0704. 63.9936. Okay, now so we have 3 approximations here. Okay, one is divided. Basically, the series was 0.1 positive, then 1 negative, 1 positive, 1 negative, 1 positive, 1 negative, and so on. So we have to truncate the series here. For first approximation, we just the first one decimal position after the decimals, and here we have used 2 positions after decimal. Here we have used 3 positions after the decimal. So we are going to divide by 2. First we divide this one by 2, and then that one by 2, and that one by 2. Okay, let's continue here. So 63.36, this approximation here by is 31.68, and it's minus 0.32. Deviation is minus 0.32. It's less than the result of 32 kilos we got before. Okay, so this is 64.064. From using that one approximation divided by 2 is 32.032. This deviation is 0.032. Okay, so this is a, here we were undershooting the results, here we are overshooting. Okay, our next approximation, if we use next one here, 63.9936 divided by 2, we get 31.9968. So deviation here is negative here. If this one is, we are undershot here, and it is deviation is minus 0.0032. Okay, let's continue. So every place we go in one step further of approximations, we are getting closer and closer, but we are bouncing back and forth of the actual value of 32 kilograms. Let's continue here. Successive approximation gets us closer to the actual answer. Okay, let's continue. Okay, let's take some example here. Pounds and kilo conversion examples here. Convert 50 kilos to pounds. Okay. First is multiply by 2, step 1, which is 50 times 2 is 100. Second step is to add a tenth of 100. Add of tenth of this number I got in first step. 100 plus 100 divided by 10, which is equal to 110 pounds. So 50 kilos we converted by 2 pounds is 110 pounds. Let's reverse that. So convert 110 pounds to kilos. Okay. Step 1 is subtracted tenth. That's my first approximation. I get a result of 99. If I subtracted 11th, then I would have gotten a, so would have subtracted 11th, then I would have gotten a better answer here. Okay. Then I would, okay, so I'm subtracting 10th, 99 now. Okay. Okay, 99 divided by 2 is 49.5, so 49.5 kilos. Okay, we started 50 kilos in approximation and lost some, and I got a 14.5 kilos. So I am undershooting. Okay, let's continue here. Next example, 33 kilos, 2 pounds. First step, multiply by 2. 33 times 2 is 66. Next step, add a tenth of this thing. Add a tenth of this thing here. So 66 plus 66 divided by 10 is 72.6 pounds. Continue here. Let's revert that. Convert 72.6 pounds to kilos. First is subtract a tenth, which is my first approximation here. 65.34. Okay. So next step is divided by 2. 65.34 divided by 2. Okay. Next is which is equal to 32.67 kilos. So this is we started with 33 and lost a 0.33 kilos in approximations. Okay. So deviation is, we are undershooting here, and deviation is minus 0.33. Okay. Here deviation was minus 0.5. It was still undershooting. Okay. Let's continue here. Another example. Convert 72 kilos to pounds. 72 multiplied by 2, getting 144. Add a tenth, 144 plus a tenth of that, tenth of this, 14.4 is 158.4 pounds. 72 kilos and 158.4 pounds. Okay. Let's continue here. Convert that back, 158.4 pounds to kilos. Okay. First approximation is subtract a tenth, 158.4 minus 15.84. Okay. That gets me 142.56. Okay, again 142.56. Okay, let's continue here. Next step is divided by 2. I got 71.28. So I'm undershooting again. Instead of 72 kilos, I got 71.28. My deviation is minus 0. Let's look the references. Main reference for this video is this Vedic Maths ebooks.com/memory mentor _maths_tips.pdf, and I get most of the ideas for the video from this write-up here. but I rarely use the same approach as this write-up does. Okay? And this write-up contains many more topics like multiplication by 11, multiplication by 12, square of numbers ending in 5, uh, adding and subtracting times, and some more. Okay, so do go ahead and use this PDF booklet here for further topics for shortcuts and tips. Okay, let's continue here. And these are my usual references for Vedic math. Uh, it's for most folks this basic teacher's manual, which is a Vedic math teacher's manual, elementary level, by Ken Williams, which you can get from vedicmaths.org, and PDF form of the book is free. This book is good enough for most of the folks, beginner folks, okay, and for the serious folks in Vedic math, researchers and teachers. This is the main reference. Vedic mathematics by Bharati Krishna Tisaji. That's the primary reference on the Vedic math. And Discovery Vedic Math is by Ken Williams, is by most complete, authoritative, and consistent notation book. But it organizes topics by sutras and not by topics. Okay? And the Vedic Math for Schools in 3 volumes by James T. Glover is a decent book, well readable, and covers most of the topics. It's probably as complete as any other book except the Kenny Williams or Tirthaji's book. So that is it. So you can go look for this tips write-up ebook, or you can look up teacher's manual elementary level, or Bharti Tirthaji's book. For tips, this is the only topic for the tips. Okay, only reference is this thing, and it has covered numerous more topics than I covered in the video. Okay, and but for Vedic math, this is the ultimate reference. Tirthaji's book, most complete. His authoritative reference to Ken Williams' Discovery Vedic Math, and Vedic Math for Schools is by James T. Glover, is a reference for is well readable and cover most of the topics. Uh, has numerous exercises and also does geometry also. Okay, okay. That's it.